All right, so this is our presentation on how the sun affects our climate. A term you're going to need to know is TSI, which stands for total solar irradiance. This is the rate at which energy from the sun reaches the top of Earth's atmosphere, and it can vary. It varies with the season, the time of day, and how far we are away from the equator, so our latitude, polar or equatorial. Because of this, our climate can actually be changed by the amount of solar energy absorbed by Earth. An example of a time when solar radiation was blocked significantly by reflective aerosols from a volcano was in 1991 when the Mount Pinatubo volcano erupted. It was a huge eruption and it caused a lot of solar energy to be blocked and did provide natural cooling of the atmosphere. All right, there's other ways that the climate can be changed by differences in solar output, which are indirect. So it's not like the sun is being directly blocked by aerosols. So one hypothesis for how these climate changes take place could be that there's changes in the amount of radiation that is in short wavelength coming from the sun, and that varies on the 11-year sunspot cycle. This will modify the amount of concentration of ozone, so how much ozone we have in our atmosphere, which will modify cloud cover and temperature, which will modify climate. The second hypothesis is that changes in solar energy can cause changes in the cosmic rays. This will create more ions in the atmosphere, and those ions modify cloud cover and temperature, again, moderating the climate. Okay, lots of information on this slide, so I'm going to go ahead and read with you so you just look at those questions you have. First paragraph, air pollution occurs when the air contains gases, dust, smoke from fires, or fumes in harmful amounts. Tiny atmospheric particles, aerosols, are a subset of air pollution that are suspended in our atmosphere. Aerosols can be both solid and liquid. Most are produced by natural processes, such as erupting volcanoes, and some are from human, industrial, and agricultural activities. So that's the answer to that question for natural examples and human origin examples. So go ahead and pause this video to go ahead and write down those two answers that I just read off to you, and then I'll catch you when you come back. All right, the next question asks, how do white aerosol particles affect solar radiation? So if you look at your paragraph 3, it says light-colored aerosol particles can reflect incoming energy from the sun in cloud-free air, and dark particles can absorb it. So think about this in the exact same way that you think about how you dress in the summer. If you're wearing dark clothes in the summer, that's going to absorb all the radiation and make you hot. If you wear lighter clothes in the summer, it's going to cool you down. You'll be nice and cool because you will not absorb those particles. You will reflect them. So on this one, I'm going to pop down to the second paragraph and read for you to answer the next question about aerosols. It asks, which type results in surface cooling, carbon aerosols or non-carbon aerosols? So let's read the second paragraph. In clear air, tiny aerosol particles interact with a solar beam. Particles containing little or no carbon are effectively white. They reflect solar radiation, making the air and the Earth's surface below them a bit cooler than they would be otherwise. Sulfate particles in the stratosphere from the Pinatubo volcanic eruption in 1991, for example, produced measurable cooling for 2 years over much of the globe. In contrast, particles containing substantial amounts of black carbon, like soot, which is typically produced from the combustion of fossil fuels, biofuels, and biomass burning, warm their surroundings by absorbing solar radiation before it reaches the ground. Since black carbon, it reflects the incoming sunlight, it also acts as a shade, and the ground surface below becomes cooler. All right, final thing today is to interpret this graph that you see, which is the global climate drivers. You'll see that the things on the top, that's the warming, and the things on the bottom is cooling. So we're looking at all these factors and what effect they have on climate. We're going to start out by looking at the purple line, and that purple line stands for small aerosol particles from urban populations. So you're looking at the amount of aerosols that are released by people in cities and the effect that that has on the environment. So since about the year 1950, there has been more of these small aerosol particles released, and it has resulted in a cooling of the global climate. Now we want to go ahead and look at the red line, which is the heat trapping emissions. Those are our greenhouse gases, our carbon dioxide, our carbon monoxide. So as you see, these gases have caused a warming trend. The question I now ask you is, which line has had a greater effect on global climate? Is it the purple line or is it the red line? And if you're looking at the slide, you'll see I told you it's the red line. And you can see that it goes up a lot higher than the purple line goes down. So its effect is that it's causing the planet to get warmer. All right, so there's 3 more lines on this graph which aren't quite as important because they don't have as much of an effect. But you will see, I want you to look at that blue line, which is the aerosols from volcanic venting. So every time we have an earth or a volcano, you would have a sharp point going down on the graph because you would have a large cooling event from those aerosols being released. You also have the yellow line for the sun's energy output. Remember, that's on a cyclic 11-year cycle, so it varies over those 11 years. And then lastly, we have the land use changes, and that's a pretty stable line as well. So finally, the last question is, which one is going to have the most effect on our global climate? And it says cooling on your slide, but I will leave that up to you to determine what do you think will happen in the future. Okay, so your next assignment is you're going to get this graphic organizer about UV radiation. You're going to be taken to a link to another YouTube video that is going to be linked on your Seesaw, so that's where you can find that. And that video will have me going through this graphic organizer with you so that you can go ahead and take notes from it. And then actually, I believe that should be the last assignment for natural causes of global warming. And then we get to switch over to human causes. So we are almost at the end of the road on these natural causes, and we're wrapping things up. So we'll see you next time.